This is the vortex tube designed for Team Icy Hot.
Invented and designed by Aaron Klump, Mariah Krebs, and Katie Renaud.
A vortex tube is a mechanism with no moving parts that uses kinetic energy to convert cold air to hot air. Compressed air enters the vortex chamber and exits out of each end of the tube system, one hot stream and one cold. Vortex tubes are typically used for cooling machines because they are less expensive than liquid coolant and require less maintenance.
The design of the vortex chamber is the most crucial aspect to the performance of the vortex tube. The chamber allows air to flow in a circular direction around the tube where the cold tube and the hot tube meet. This creates the necessary vortex motion so air can enter the tube at high velocities through the four tangent openings.
As the air spins down the tube toward the hot end, the kinetic energy in the air movement causes the air temperature to increase along the walls and decrease in the center. To separate these two streams of air, a cone attachment is fixed at the hot end. Since the hot air is on the outside, it escapes out of the tube along the angled sides of the cone. The cold air in the middle strikes the tip of the cone and bounces back toward the opposite to exit out of the cold side.
Both the cold and hot streams continuously flow in either direction throughout the length of the tube. To prevent hot air from mixing with the cold air and escaping out of the cold end, a metal disc with a small hole in the center is placed in between the hot and cold tubes within the vortex chamber. Cold air will continue through the clearance hole, and hot air will bounce off the metal disc and change direction toward the hot end. All connection points between the different materials are sealed to prevent air loss and therefore increase the temperature difference between the air exiting the hot and cold tubes. Temperature difference can be predicted assuming isentropic expansion in the tube. Using the properties of air at atmospheric pressure and the known pressure entering the vortex chamber, the predicted temperature difference is 36.2 degrees Celsius. Experimental results yielded a temperature difference of 38 degrees with an error of less than 5%.
Overall, the purpose of a vortex tube is to maximize the temperature difference of compressed air and provide an alternate process for refrigeration systems.